Yeah, so I'm super excited to do this co-webinar with Isola and Alex. I think it's really important to have material experts available to you as designers as you're designing your product. There's already so many things to consider. Materials is a very important aspect of your design process. So I really welcome this continued partnership and presentation. So thanks, Alex.
Thanks
So
for having me. Yep.
yeah, absolutely. So let's go to so Sierra Circuits, if you haven't gotten a quote from us yet, please do so. So we are a full service PCB fabrication and assembly company. How are we different from the big guys? Most of the big guys don't have their own, most of the big assembly companies don't have their own PCB shop. We don't outsource our PCBs, we make them ourselves, hence this type of webinar. And we also do our assembly process in-house as well. So we're about 150,000 square feet of manufacturing between fab and assembly. So this is the table of contents for today's discussion. I think all of it is stuff at the beginning might be motherhood and apple pie, but I think at the end, lots of good discussions can come out and very important discussions. And as always, I encourage lots of questions because even though we've been doing this for a long time, we don't know everything, and sharing is good. So ask a bunch of questions. So first is, what are the factors to consider when selecting RF PCB materials specifically? And the first is the electrical properties of the materials, and dielectric constant, I would say, is the first and foremost. And dielectric constant of your material will directly affect how quickly your signals travel through the traces. And so the higher the decay, the lower the signal propagation rate. And then materials with high decay are prone to more inductive and capacitive coupling. So be really aware of the decay value of the material that you're selecting, that it's right sized for your requirement. So not only is the decay important, the other thing that's important is the glass weave of the material that you're choosing. So we recommend a 1067 weave with better uniformity, and it would reduce signal integrity issues. The better materials you choose, the less issues you're going to have. If you have a high-end requirement, so that's really important. Tilting your board is a solution, but no fabricator likes that solution. Instead, pick better materials with better weave. That's our recommendation. The next key electrical property is your dissipation factor. So the dissipation factor measures how much signal loss occurs in your dielectric material. A higher DF is greater signal attenuation and increases insertion loss. So you want to choose materials with dissipation factors like 0.005, and here are some examples that Isola has. These are all easy to work with as a fabricator, so that's a key point we'll be hitting later. How does a material process? And then lastly, CTE is a critical material property as well. And what are the thermal properties? And you want to select materials that don't aggressively expand, especially if you have a structure like a via and pad underneath the BGA, or you have stacked vias. You need to pay special attention to what your budget is for the thermal connectivity as well as the CTE. Next, in selecting your PCB materials, you should consider the copper roughness. So copper roughness applies to both sides of the copper that is interfacing with the core material, and then the copper roughness that essentially is created by the fabricator to bond to the prepreg. So copper roughness is needed to bond to both sides of the material. And ISOL will be discussing this in a little bit more detail. But you want to minimize any skin effect losses. And this is one way to do it, is by picking low profile copper and understanding how your fabricator is, what kind of chemistry your fabricator is using to roughen up the copper as well. And I think we have next is a quick demo of our impedance calculator.